Hello everybody, welcome into another lesson. So today we are going to talk about direct variation. Well, what is direct variation used for? You'll often find that if you go into the science fields, especially in physics or even somewhat in chemistry or biology, or if you're dealing with nuclear stuff such as radioactive decay or dealing with geology for carbon dating or dealing in engineering. If you go into engineering, you'll find direct variation comes into play a lot. There are a couple types of variation. We have direct variation, which we're going to talk about today. Next lesson, we're going to talk about the second type called inverse variation. And then the third type really combines the two that I mentioned. It's called joint variation, but it just combines direct and inverse variation. So today we're going to stick with direct. So direct variation, you have the form of the equation y equals kx, where k is called your constant of variation. So in these problems we're going to solve for the constant of variation and get the new equation once we have that constant of variation. How you read problems in direct variation, how you translate it is y varies directly as x. If you see something like y varies directly as x, it translates into y equals kx. Directly means they're equal to each other. You just have that k, that constant of variation. So that's how that would come into play. So we're going to do some problems here. Use this marker. Find the constant of variation and the resulting equation. So in these problems, what we're going to do is we're going to find the constant of variation first, then we will find the resulting equation once we know the constant of variation. So let's get started with our first example here. Y varies directly as x when y equals 9 and x equals 54. Okay, so we have y varies directly as x when y equals 9 and x equals 54. So let's start with the first part. Y varies directly as x. What the y varies directly as x translates into is y equals kx. That k, again, just your constant of variation. It goes along for the ride. Really, y varies as x. That constant of variation just goes along with x, hangs out for the ride. Well, now, first thing we're being asked to solve for is the constant of variation. We have y equals kx. Well, we want to solve for k, right? Well, we'd have to divide that kx by k. So let's do that now. You'll get k is equal to y over x, because what you do to one side, you got to do to the other. So, and this is actually how direct variation, excuse me, this is how direct variation equations work. The constant of variation is always equal to the y over x. Now, in this case, they give us that we want to find the constant of variation. They give us that y equals 9 and x equals 54. So k equals 9/54, which 9/54 will reduce to 1/6. So the constant of variation is going to be 1/6. That is the constant of variation would be 1/6. So we've figured out the first part. The second part is the resulting equation. That's easy. All you're going to do is keep your y, set that equal to your k, which is 1/6. That's your constant of variation, is 1/6 times x. So the resulting equation from this is y equals 1/6 x. So we have a constant of variation of 1/6. The resulting equation from that is y equals 1/6 x. And I do got more examples here. All right, what's next? Y varies directly as x when x equals 72 and y equals 6. Alright, so y varies directly as x when x is 72 and y equals 6. Okay, well, let's start with the first part. Y varies directly as x. That translates into y equals that constant k times x. So y varies directly as x. Y equals kx. First, we're being tasked with, we're going to be tasked with solving for the constant of variation. Again, we want to isolate that k by itself, right? So we got to divide by x. So if we do that, you get that k by itself, the constant of variation, you end up getting y over x. So now we've established the equation for the constant of variation. Let's get to finding what that constant of variation is itself. What that is, let's see, that constant is equal to the y, which in this case was 6, over the x, which was 72. Well, 6 72nds, that reduces to 1/12. So the constant of variation for this particular equation is going to be 1/12. So 1/12 is the constant of variation. So we found the constant of variation. Now we need to find the new resulting equation, which would be y equals that constant of variation of 1/12 times x. Therefore, the resulting equation is y equals 1/12 x. Alright, let's see. This is a little bit different. T varies directly as S when T equals -16 and s equals -2. Okay, so you can have direct variation with other variables too, but it's going to work the same way. T varies directly as s when t equals -16 and s equals -2. So let's start with the first part. T varies directly as s. That means t equals that constant of variation k times s. So t varies directly as s. T equals ks. Well, first thing we're tasked with finding is that constant of variation. We want to get that k by itself, we got to divide by s. So if we do that to the right-hand side, you get k. That's going to be equal to t over s. So the constant of variation is equal to t over s. Now to find the constant of variation, since we have the equation, we just plug in the values of t and s. So the constant of variation is equal to the value of t, which is -16, over that s, which is -2. So the constant of variation is going to equal -16 divided by -2. That's +8. So the constant of variation in this particular case is 8. Second part, let's find the resulting equation. You're just going to keep your t, set that equal to your constant of variation of 8 times your s. So t equals 8s would be the resulting equation using your constant of variation. Let's see. H varies directly as m when h equals 112 and m equals -16. Alright, so we have this one here. H varies directly as m when h equals 12 and m equals -16. So start with the first part. H varies directly as m, so that means h equals to that constant of variation times m. So h equals km. That's what you would get for your initial equation. Now we want to find the constant of variation. That's the first thing we're being asked to find. To find the constant k, you're going to have to divide by m. If you divide the right side by m, you get k by itself. That's going to be equal to h over m. So that equals h over m. Now that we have the equation for the constant of variation, what we need to do now is plug in the values of h and m. So k is equal to the value of h, which is 112, over the value of m, which is -16. And then we'll get a true value here when we do the division of the constant of variation. So let's take 112 divided by -16. You get -7. So your constant of variation is going to be -7. That is your constant of variation, -7. Last but not least, you need to find the equation. So you keep your h, that's equal to your constant of variation of -7 times the m. So therefore the resulting equation from this is h equals -7m. And good, y'all could see. Perfect. Alright. Now, a little bit different here. W is directly proportional to M. W equals 150 and M equals 6. Well, very interesting thing here. This is a bit different wording. W is directly proportional to M. Let's start there. W is directly proportional to M. That means that they're in a fraction to each other. So you take the first one, if W is directly proportional to M, that means it's W over M. You'll get W over M, and you'll just set it equal to the constant of variation. So this is W is directly proportional to M, and that means it's going to be W divided by M. You set that equal to the constant of variation. Well, we got our work cut out a little bit for us here because we want to find the constant of variation. Well, we already got the values of W and K. All we have to do is plug them in. 150 for W over 6 for M. Now we just got to take 150 divided by 6. I used to know it. Yep, 25. So your constant of variation in this particular equation is 25. So, yes, your constant of variation does turn out to be 25. Now, we need to find an equation where they are directly, where W is directly proportional to M. Well, let's go to the original equation. We want to make W directly proportional to M. That means we need to get M out of the left-hand side, move it over to the right. The only way to do that is to multiply both sides by M. If you do that, you multiply the left side by M, you get W. That's equal to K. Then you multiply the right side by M, you get M. So W equals Km. Now all we got to do to find the new equation is put in that constant of variation. So W will equal that constant of variation of 25, then M. So W equals 25M is the equation for the direct variation in this case. So, and I do have another problem like it. I got another problem identical to it almost. Just different variables, but it's pretty similar. Let's see, P is directly proportional to T. Then we're given P equals 210 and T equals 14. So, alright, we have P is directly proportional to T, where P equals 210 and T equals 14. So P is directly proportional to T. Start with that. That means it's going to be in a ratio of P to T. So P is directly proportional to T. It's in the ratio P to T. You set that equal to your constant of variation. Again, to solve for the constant of variation, we got our work cut out for us. All we got to do to solve for is put in that value of P, which would be 210, divide that by your value of T, which is 14, and then let's solve for that constant of variation. $210 divided by 14 is 15. So your constant of variation in this particular case is going to be 15. That's what you would get. Your constant of variation would in fact be 15. Now we need to solve for the equation. Whenever you start with P is directly proportional to T, it's always going to turn into P, how do I word that? P varies directly as T. It'll turn into P varies directly as T after the fact. So it may start P is directly proportional to T, but once you found your constant of variation, it's going to turn into P varies directly as T. So in order to make it P varies directly as T, that means we have to get the T out of the left-hand side, move it over to the right. Well, in order to get rid of T from the left-hand side, since you have a T in the denominator, you got to multiply both sides by T. If you multiply the left side by T, you just get P. Then you multiply the right side by T, you get KT. So P equals KT. Now, all we have to do to find the equation is put in the constant of variation. You'll get P equals that constant of 15 times T. Therefore, the new equation you get is P equals 15T. Alright. So that's it for those. I got 4 more problems, but they are a little bit different. They are just a little bit different. Okay. Let's see. Y varies directly as X Y equals 450 and X equals 6. Find Y when X equals 10. Alright, this one seems a little more loaded. We have Y varies directly as X. They give you Y equals 450 and X equals 6. Then find Y when X equals 10. Start out right away. When you have a problem like this, ignore the last sentence for just a minute. Forget about the find Y when X equals 10. Forget about that. First start with Y varies directly as X, which will be set up in the form Y equals KX. Alright? Well, what we're going to do here is we're still going to first solve for that constant of variation. In order to solve for the constant of variation, we have to get the k by itself, which means we got to divide both sides by x. So if you divide the kx by x, you do get k by itself. That'll be equal to y divided by x. which if we want to find the constant of variation, all we got to do now, start with your initial values of y equals 450 and x equals 6. So that's going to be equal to 450 divided by 6. So then we're about to get the true value of the constant of variation. Let's do 450 divided by 6. I should know that. No, never mind. 450 divided by 6, that's 75. So the constant of variation turns out to be 75. So I'm gonna put a box around the constant of variation being 75. Alright, so now like we've been doing, for a moment, continue to ignore the find y when x equals 10. Just ignore it, pretend it's not there for a minute. Now, let's find the equation of variation. Let's find a new equation. That's simply going to be y equals that constant of variation being 75 times x. So y equals 75x is going to be your equation. But there is actually a third part to this. So we found the constant of variation, we found the new equation that involves the constant of variation. Now the last thing, they want you to find the value of y when x equals 10. So once you found your constant of variation in the new equation, you can finally pay attention to the last sentence of find y when x equals 10. Well, all you're going to do is take your y, set that equal to 75 times that x value of 10. Well, 75 times 10 equals 750. So the answer is when x equals 10, y equals 750. But in order to have obtained that result, first you have to find your constant of variation, then the new equation, and then you can come out with your final result. And I got more examples like this. All right. Let's see. D varies directly as Z D equals 6 and Z equals 48. Find D when Z equals 20. Alright, so we have the problem here, D varies directly as Z. Well, D equals 6 and Z equals 48. Then find D when Z equals 20. So, to start with, ignore the entire last sentence. Forget it's even there. Start with the first part, D varies directly as Z. Well, D varies directly as Z translates into D equals KZ. So you have D equals KZ. Well, we want to first get the equation for the constant of variation. In order to get that K by itself, we got to divide both sides by Z. You divide KZ by Z, you just get K. That'll be equal to D over Z. So that's the equation to obtain the constant of variation, K equals D over Z. Now, once you've obtained the equation for the constant of variation, you're just going to plug your values in. So D is equal to 6, Z is equal to 48. Therefore, the constant of variation is going to end up being, what's 6 over 48? That's 1/8. So we have obtained the constant of variation to be 1/8. So that's one part of the puzzle we need. Now the next part of the puzzle is to find an equation of direct variation. You're just going to keep the D, but you'll insert the value for your constant of variation being 1/8 times Z. So the equation is going to be D equals 1/8 times Z. Now there is one last part of this to obtain. We want to find out the value of D when Z equals 20. Now we focus on that. All you're going to do is you're going to put in 20 for Z. So D equals 1/8 times 20. Well, 20 and 8, they both have a 4 in common, do they not? You divide 8 by 4, you get 2. Divide 20 by 4, you get 5. Therefore, D is going to be equal to 5/2. So when Z is equal to 20, D equals 5/2. That would be the final answer. So again, first obtain your constant of variation, then obtain the equation of variation, and then you can go ahead and proceed. Once you got that equation that contains the constant of variation, you can stick in the assigned value to obtain the value you desire. I got about 2 more problems, then we're done for the day. Let's see. H is directly proportional to A. Whoops, to what? To A. H equals 425 and A equals 8.5. Find H when A equals 12. Alright, so this problem here, H is directly proportional to A. H equals 425 and A equals 8.5. Find H when A equals 12. Alright, so this time it's written as H is directly proportional to A. That means H divided by A. H divided by A is going to equal your constant of variation, K. That's how that would be set up. Now, we got our work cut out for us a little bit to find the constant of variation, because all we got to do is put in the value of H, which is 425, divided by that value of A, which is simply 8.5. Therefore, that constant of variation, let me go on ahead and do the division here. 425 divided by 8.5, well, that's 50. Therefore, the constant of variation is equal to 50. Well, that's great and all. We got the constant of variation. Well, For a type of problem like this, we have two options. We can either find the equation how it actually should be, which would be h equals ak, or since we've obtained our constant of variation, that's equal to 50, we can leave this alone. What we can do next is going to make this easier. They want us to find the value of h when a equals 12. How you're going to set this up is h over 12, because a equals 12, that's going to be equal to k, your constant of variation, 50. It just saved you some steps from having to find the equation when it really wasn't necessary in this case. So once you've obtained your constant of variation, you've answered that. All you got to do now is look at the last sentence here. Find h when a equals 12. Well, h is directly proportional to a. That means h is proportional to 12 equals the constant of variation of 50. Well, we want to solve for h. All you're going to have to do is multiply both sides by 12. If you do that, the left side you just get h. On the right side you multiply 50 by 12, you get 600. So the result that you get when a equals 12 is h equals 600. And I got one more problem, and it's pretty much like this one. Alright, what's this one? R is directly proportional to A. Okay, let's see. R is directly proportional to A. R equals 14 and A equals 87.5. Find R when A equals 25. Okay, so we have the problem here. R is directly proportional to A. R equals 14 and A equals 87.5. Find R when A equals 25. So to start with, ignore the last sentence, pretend it doesn't exist. Start with R is directly proportional to A. That means it's going to end up being R over A. You just set that equal to your constant of variation. So R over A equals K, your constant of variation. Now, we got to solve for the constant of variation to start. All you got to do is plug in your assigned values for R and A. Your initial assigned values are R equals 14 over that A equaling 87.5. Well, now we just want to find the constant of variation. Which, let's see, that comes out to be 1600ths, 850ths, 425ths. So the constant of variation turns out to be 425ths. Because the decimal is 0.16, which you know is 1600ths, that reduces to 425ths. So your constant of variation is going to be 425ths. Well, what we can do now, we've solved for the constant of variation, we can focus on the last sentence. Find r when a equals 25. Well, we don't know r, that's okay, but we do know a. A is certainly 25. That's going to be equal to your constant of variation, which was 4 25ths. Well, what do we have here now? We have a proportion. Just take the cross product, set them equal to each other. R times 25, that's 25r. That's going to equal 25 times 4, which is 100. And then to solve for r, you just divide both sides by 25. R is equal to 100 divided by 25, which is 4. So the answer we're looking for here is when a equals 25, r is 4. So starting with these problems, you're always going to set up your equation. If it varies directly, that means it's going to be something in the form of y equals kx or t equals ks. Very similar setup. If it varies proportionally, that means you're going to take r over a and set that equal to your constant of variation. But in either case, first find your constant of variation, and then next thing you want to do is find the new equation that's involved when you have your constant of variation. And then if you have a problem like find r when a equals 25, you'll do the third step and do just that. You'll solve for the r when you plug in the assigned values like we just did. So that's it for direct variation. Next lesson will be inverse variation. So I hope everybody has a good night. Take care.